All right, hi guys. This video is additional help on ellipses, so hopefully this can clear up any confusion that any of you guys might have. So before we take a look at number one, I just want to talk about like the generic form of an ellipse. We have x minus h squared, again what we're usually familiar with, plus y minus k squared, again what we're usually familiar with. And then we have fractions this time, so we've got a denominator of a squared or a denominator of b squared, and it is always set equal to 1. So just some facts about the denominator, the a squared and the b squared. A is always going to be the bigger number, okay? So that's what this means. A is not linked just to x, okay? So the denominators are flexible. So what that means is you can also see the generic form look something like this. It can be the x minus h squared plus y minus k squared, except this time b squared can be under h or a squared can be under h. It's still going to be set equal to 1. So because a is always bigger, a is always going to be the vertices, okay? No matter what direction the ellipse is oriented, okay? So A is bigger, A is the vertice. That means B is always going to be the co-vertices. If it helps you remember, think of like a pilot and a co-pilot, right? That like this one's more important than this one. Again, no shade to co-pilots anywhere. But remember, the bigger number is the vertice because it's the one that's in charge. The smaller number is the co-vertice because it's the secondary one. So what that means is when A is underneath the x-axis, right, we should know, or yeah, it's easy to think about them like axes, right? So if you've got your y-axis, that means vertical. Your x-axis means horizontal. So when the bigger number is under the x term, that means that it's going to be longer than it is tall, right? So you're going to be looking at an ellipse that's more like horizontally axis, or yeah, horizontally, I don't know the word, oriented. That's the word I'm looking for. Whereas down here, when you see A under the Y term, that means that it's going to be bigger vertically than it is left and right. And so you're going to have an ellipse that looks more vertically oriented. So that's kind of just the breakdown of the generic form. So knowing what we know about that, we're going to jump into number one, and we'll talk about foci when we get there. So we're going to identify the center, the vertices, the co-vertices, and the foci of each thing, and then sketch the graph. So the first thing that I'm going to do is I'm going to look at my h and my k because that's the easiest thing, and I've been doing that the most often. So I'm going to flip the signs on both of those and go to -1, -3. So my center is -1, -3. So now the next thing I'm going to do is I'm going to look at my diameters, or sorry, not my diameters, my denominators, and I'm going to decide which one of them is bigger. Once I do that, then I know which one's A and which one's B. So I'm going to label this one as A squared and this one is B squared. So what that tells me is that the vertices are going to be more horizontally oriented, and that the ellipse is going to look horizontal. And so if A squared is 36, then A is 6, and if B squared is 16, then B is 4. So from the center, because A is underneath the X term, that means X is horizontal, so I'm going to go 6 left and 6 right. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Clean it up. Oops, sorry. Okay, I knew to go left and right because the X term is horizontal. Horizontal is left and right. A was under the X term, so A means left and right. So B is under the Y term. B means up and down, or sorry, Y means up and down. So I'm going to go 4 up, and I'm going to go 4 down. And so what I like about doing it on a graph is it makes it really easy to write it out. My vertices are at -7, -3. And then my, I've got 5, -3. And then my co-vertices are at -1, +1, and -1, -7. And then I'm going to sketch my graph. I'm going to connect these dots in a rough drawing of an ellipse. And then the last thing is the foci. The foci go in the same direction as the vertices. Okay, so I'll write that down. Foci are in the same direction as the vertices, always the vertices. The foci is C in each direction from the center, the same direction as the vertice. And C can be found with this equation. And so foci suck, which in my opinion makes ellipses the worst conic section, because the A and the B numbers aren't always nice numbers, which means that sometimes C is a radical, and yeah, it's just super ugly. You guys have a test coming up eventually on this, and I've tried to keep the numbers away from really nasty foci, so hopefully that helps make the process easier. But anyway, so in this case, if I want to find C, A squared is 36, B squared is 16, which means C squared is 20, square root both sides. C is going to be 2 root 5, because you factor out the square root of 4, and then you're left with the 5 under the radical. So what that means is I have to go 2 root 5 in each direction from the center in the same direction of the vertices. So what I would do is I honestly would go to a calculator and I would just get an estimation of what 2 root 5 is, just for my solving purposes. So it's about 5. Well, it's about 4.5 actually, if that helps make it easier. So I'm going to go about 4.5, 1, 2, 3, 4 in each direction. 1, 2, 3, 4. So those are my foci. But to make it accurate in the foci, because we're not going to estimate it with decimals or anything, we are going to say that our foci, they're going to have the same y coordinate as the center because they're in line with the center. So that means I'm going to take the center and I'm going to add 2 root 5. Oops. And I'm going to have the same y coordinate. And then I'm going to take the center and I'm going to subtract 2 root 5 and have the same y coordinate. So the adding symbolizes going to the right and doing my dot, and the minus represents going to the left and putting my dot down. And that's it. So the center vertice co-vertice thing, not the worst thing in the world. Foci, kind of tricky, but easy when you think about it graphically. So then let's take a look down here. We want to locate our center. I think that's right. Let me check. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3. Yep. So finding the center, honestly, you just kind of have to eyeball it first and then do what I did and check and make sure it's equidistant in each direction. So from there, you can label your center. It looks like I'm at 2, 4. And then my vertices, as you can see, the ellipse is horizontally oriented, which means that X is the term that has the A with it, and that means that the vertices are going left and right. Again, the vertices are always going to be the farther points out that make the ellipse oval or oblong shaped. So my vertices, it looks like they're at 7, 4, and -3. 4, my co-vertices are here and here. Co-vertices are always going to be the shorter distance out, so... Oh, it's not even asking me to write those. Sorry. It's not wrong, though. No, we need to know the center. So we know the center. And so what we need to know is we need to know A, the bigger distance, which is 5. And we need to know B, the smaller distance, which is 3. And so then it's actually really easy, because I'm going to do x minus 2. Make sure you flip the signs. Plus y minus 4 squared equals 1. And then I know the bigger denominator is going to go underneath the x term because it is bigger horizontally than it is vertically. And so I'm going to put a squared, which is 25, and then that means b squared is going to go underneath the y. The great part about ellipses, though, is that it doesn't matter whether it's like the x first or the y first, because it's addition. So there is no like order of the x versus the y. But typically we write it x plus y. So like the top half basically looks like the equation of a circle, and then it's got denominators which make it not a perfect circle. But yeah, let's take a look at number 3. Number 3, I think the best thing you can do is think about it graphically. I think thinking of it on a graph is the most easy thing to comprehend. So this, trying to make sure I estimate this well. So this is -9, and then this is -10, and then we'll call this +16. So not great, but that'll do. So we've got one vertice at -9, +16, and we've got another vertice down here at -10, or -9, -10. And then we've got -9, 8, which is going to be about here. And then we have -9, -2, which is about here. I know that's really not a great version of it, but you can lightly sketch an ellipse through that if you'd like. And then what we're going to do is we're going to figure out what is this distance from the center to the vertices. So this right here is a 26 point spread. So right in the middle of that would be 13. Like if I split it in half and went 13 in each direction. So that means that the center is actually going to be like right here at +3, because from +3 to -10, that's 13. From +3 to 16, that's 13. So I know my drawing sucks because it does not look like the center at all. But we're gonna say that the center is like right there, and we're just gonna go with it. So we're gonna jot down that our center is gonna be at -9, +3, and then we need to know the distance from the center to the vertices. That's gonna give us A. So that one's really easy. We just talked about that. A is 13. The struggle is that we don't know what B is, okay? So B is a question mark because we don't know where the co-vertices are, but we know where the foci is. And so remember, distance from center to vertex is A. I'll write that down. Center to vertex is A. Center to covert is B. And then center to foci is C. So when we don't have B, but we have A and C, because we do know that distance from the center to the foci, then we're going to just use the equation to work backwards and find what B is. So C is the distance from the center to the foci, and if we can see the center is at -9.3, then to go up to -9.8, that's 5. To go down to -2, that's 5. So we know that C is 5, which means that we use the equation C squared equals A squared minus B squared. We plug in what we know. 5 squared equals 13 squared minus B squared. 25 equals 169 minus B squared minus 169 on both sides. And what does that give me? It gives me -144. Beautiful. Divide the negative away. 144 equals B squared, which means B gets to be 12, which is awesome. And now we know everything that we need because to write the equation, all we need is the center A and B. And I'm going to change my color just so we can see the answer. So I'm going to flip my signs. Choo-choo. And then if you look, the parabola is oriented. It's more vertical than it is horizontal, which means that the bigger number needs to be under y. Okay, so when the ellipse is tall and the vertices go up and down, the foci go up and down. If the center, foci, and the vertices are all in a vertical line, that means that the y gets the a term, the bigger term, which is what makes it vertically tall. So a squared is going to go under y, and b squared is going to go under a. And that's it. And then last but not least, we got a completing the square problem, because we always do. This is going to be like circles again. We're going to have to complete the square for both of them. And this time we're going to factor things out, because you can't complete the square when a or x squared or y squared have an a term. So that's where our denominators are going to come from. So the first thing I'm going to do is I'm going to group. So I'm going to do 4x squared minus 48. Put the x's together. 9y squared plus 90y, and then I'm going to add 207 to both sides so that it's not hanging out over here. So now the next thing, I have to factor out the GCF if the squared term has a number in front of it. So I'm going to factor out the 4, which gives me x squared now minus 12x, and then this is the polynomial that I'm going to complete the square with. So I'm going to do half of negative 12, which is negative 6, and then negative 6 squared is positive 36. Awesome. And then I'm going to factor out a positive 9, and leaves me with y squared plus 10y. And again, that is the number that I'm going to complete the square with. So half of 10 is 5. 5 squared is 25. Equals 207. And now here's the trickiest part. Here's where I think like 90% of our struggle went wrong. You have to acknowledge like where this number is in the equation when you plugged it in, because we're good at being honest and saying, oh, I added 36 to this side, I should add 36 to this side as well, but you didn't add 36 to the left side. You added 4 times 36. You put 36 in a parenthesis that had a coefficient in front of it, and that means that if I expand it out the left side, it should match the right side. And if you don't remember to multiply that coefficient by that number that you invented, if you expand the left side, it's not going to equal the right side. So I actually don't know what 4 times 36 is, so I'm doing that on my cell phone calculator while I stall. So that's 144. And then same thing over here. I'm not going to add 25 to the right side because I didn't add 25 to the left side. I added 9 times 25 to the left side, which is 225. And so now I've got 4. And then the reason I made this polynomial so that it would factor perfectly, this is going to factor to x minus 6 and x minus 6. And of course, hopefully we're getting familiar by now. We don't want to write x minus 6, x minus 6. We want it to start looking like the generic formula. And so that means I'm going to say x minus 6 squared plus 9 times y plus 5 squared equals, and then I'm going to figure out what 225 plus 144 plus 207 is. And that leaves me with 576. And so now we still don't have the final equation. And the reason that we are going to get some denominators in a couple seconds is because the generic form is always equal to 1. Okay, so if we look down here, our completing the square was really nice and pretty, but it does not equal 1, so it's not in the generic form of an ellipse. Therefore, I divide everything by 576, and then what I would do is I would just simplify these fractions. So I'm gonna, I guess I can do it on my iPad calculator so you guys can see. So I'm going to do alpha y equals, and then I'm going to do 4 over 576, see what it reduces to, 1 over 144, and then I'm going to do the same thing, with 9 over 576, and then math fraction, and 1 over 64. So that brings me back here. my 4x minus 6 squared over 576 plus 9, y plus 5 squared over 576. Oops. Equals 1, and then these guys reduce. The 4 over 576 reduced to 1 over 144. So that's x minus 6 squared over 144. And then the 9 over 576 simplified to 1 over 64. So it's 5 squared and then 64. All equal to 1. Yeah, so I hope that helps. I'll zoom out right now if you just want to pause and use this moment right here as an answer key. I hope that helps. I do think that ellipses are the most tricky. I think circles are the best, parabola next, hyperbolas are pretty good, and then the foci make the ellipses a little tricky in the moving a squared and b squared term. But let me know if you guys have any more questions. Remind, Google Classroom, email, you know how to reach me. Yeah, I miss you guys so much and can't wait to see you guys again. Love ya. Bye.